This is section 6.5, adding and subtracting rational fractions, and this is part 2 where we will work on problems that have unlike denominators. So when we see a fraction, and we always want to start off basic, something that we're familiar with. So basic fractions where you have unlike denominators, the first thing you have to do is you have to look at those denominators and you have to find a common multiple. So LCM, we haven't done LCM yet. So LCM C always stands for circle the common, but this time the L stands for leftovers. Leftovers, what do you mean leftovers? Well, let's do the prime factorization for 4. Which is 2 times 2, and the prime factorization of 2 is just 2. So we circle what they have in common. And now what we do is we're going to circle the leftovers. So my LCM is what they have in common. They have a 2 in common, and whatever they have left over. They have a 2 left over. So my LCM, or my common denominator, is going to be 4. So that is always going to be step 1. And step 1 is relatively familiar. Step 2 should also be familiar. We're going to be, does it say? Find LCM. Step 2 is going to be find equivalent fractions. So now that we have the common denominator, we have to change those to equivalencies. So 3/4 equals how many 3/4? Well, that's easy. Times 1 times 1. So 3/4 equals 3/4, yes. Or 3/4 equals how many fourths, the question should really sound like. And now let's look at our other fraction, 5/2. So 5/2 is equivalent to how many fourths? Well, 2 times 2 equals 4. So if we multiply the denominator, we have to multiply the numerator by 2 in order to keep it equivalent. So you get 10/4. So now we have the same denominator. So now we're back to day 1. So we can combine their numerators over the same denominator. Those are like terms. So we get 13/4. Let's do one that's a little bit more complex. Let's do 3/12 plus 4/15. Yeah, I like that. All right, so step 1, find LCM. Let's do the prime factorization of 12, which is 2 times 2 times 3. 15 is going to be 3 times 5. Let's circle what they have in common. They only have a 3 in common, so they're going to have a lot of leftovers. They have a 2 as a leftover. They have another 2 as a leftover. And they have a 5 as a leftover. So my LCM is going to be what they have in common, a 3, and then whatever they have left over, a 2, and a 5. So that's 6 times 10. So 60 is going to be the common denominator. Now step 2 is equivalencies. Let's find equivalent fractions, fractions that are equivalent. 3/12 is equivalent to how many 60ths? Well, that's 2 times 5, I think. 5 is 15. Right? Yeah. Yes. 15. I don't know why I thought I might be wrong. 4/15. Now let's convert 4/15 to 60ths. That would be times 4 times 4 is 16. Now we have like denominators, so we can put them over the same denominator, and we get 31/60ths. All right, so those are the basic ones. Now let's do something a little bit more complex. So just because it looks more confusing doesn't mean you have to change what you're doing. Find LCM. You should be comfortable with this, 2x squared. We can find the prime factorization of 2x squared. It's 2 times x. And 4x is going to be 2 times 2 times x. And we, again, will go back to circle the common. They have an x in common. They have a 2 in common. And now let's circle the leftovers. They have an x left over and a 2 left over. So my LCM is what they have in common and what they have left over. And 2 times x times 2 is 4x squared. So my common denominator is 4x squared and 4x squared. Now let's find equivalencies. So equivalencies, let's look at that. 2x squared, 1 over 2x squared. 1 over 2x squared equals how many? 4x squared. So what do we multiply 2x squared to get 4x squared? Well, we multiply it by 2. 1 times 2 is 2. That seems really easy, doesn't it? Now we have 5 over 4x. 5 over 4x equals what over 4x squared? So what do we multiply 4x to get 4x squared? Well, it's missing an x. So we multiply it by x. 5 times x is 5x. We get 5x. And now we can put them over the same denominator. But let's remember to put it in standard form. Instead of writing 2 plus 5x and then having to rewrite it. So we cannot factor that numerator. We cannot cancel anything. So that would be our answer. Not too bad, right? That seems very reasonable. So we have 3xy, which equals 3 times x times y. We have 2x squared, which equals 2 times x. They have an x in common. Everything else is a leftover. So we have my LCM is going to be 2 times, times 3 times x times y. So the x is what they have in common. Then the 2, the 3, the x, and the y are the leftovers. So my LCM is 2 times 3 is 6. X times x is x squared y. 6x squared y. 6x squared y. Let's find equivalencies. So we have 4 over 3xy equals what over 6x squared y? So let's look at the coefficients. 3 times what is 6? Well, that's 2. And then xy to xy squared, well, we're just missing an x. So we're going to multiply it by 2x. That gives us 8x in the numerator. Let's look at the other fraction. 3 over 2x squared. 3 over 2x squared. Make sure I wrote that correctly. Good. What do we have to multiply to get 6x squared y? Well, 2 to 6, that's times 3, and then x squared is good, but it's missing a y. So we need to multiply it by 3y, which makes 9y. So we get 9y. We have like denominators. Let's put them over. Alphabetical order in standard form. There is no common factor, no common coefficient in 8 and 9, and no common variable in x and y. So that would be my answer. I can't add 8x and 9y because those are unlike terms. This is good. So here's a nice little tricky one. Step 1, LCM. So when we have 5 times the quantity x plus 1, when we find the prime factorization of that, that's 5 times x plus 1. And then when we have x plus 1, the prime factorization is x plus 1. We can't break up addition and subtraction. We can only break up multiplication. That's prime factors. Factors are multiples. Or multiplication, things being multiplied. But they do have that in common. And then 5 would be the leftover. So my LCM would end up being 5 times the quantity x plus 1. They have an x plus 1 in common, and then the 5's the leftover. So let's put those both as the common denominator. We are not going to distribute the 5 into the x plus 1. We like them as products. We like them factored. So now we want to find common. So 4 over 5 times the quantity x plus 1 equals what over 5 times the quantity x plus 1? Well, it's the same thing, right? So that numerator stays the same. Let's look at my other fraction. I think I have x over x plus 1 equals what over the quantity 5 times the quantity x. So what's this missing? It's missing a times 5. So that makes 5x. 5x. Now we have common denominators, so we can combine the numerators. I'm going to write it in standard form. And these 5s can't cancel because that 5 is multiplying the x and adding the 4. We can't factor the numerator, so we just leave it like that. Same thing. And now you should be starting to get better at looking at this and seeing what the LCM might be. So we have x minus 3, which cannot be broken. 2 times the quantity x minus 3 is 2 times x minus 3. They have an x minus 3 in common, and they have a 2 left over. So my LCM is going to be 2 times the quantity x minus 3. 2 times quantity x minus 3 minus, woohoo, I see that minus. Was there a minus in any of those other ones? Let's hope not, because I did not see it. Oh, there was a minus. Mr. Mac. See, I felt it. I felt like I was doing, whoa, this is going to change the answer big time. Sorry, we got off on a tangent. Oh, Mr. Mac, I know you were telling me way back on 19, Mr. Mac, you forgot the negative. Well, that negative gets attached to that the 5x. So when we write it in standard form, oh, baby, I'm sure you were just couldn't wait. You probably already emailed me that I made a mistake. Now, what's wrong with this? We got to factor out that negative. So if we factor out the negative, because we can't have a first term negative, you get that. Now, that could be your answer, but there's a better way to deal with that negative. Let's take it and put it in the denominator because there's a monomial down there. If there wasn't a monomial, if it was 2 terms, then you just leave it up in the numerator. But this is the best answer. That's the best high school answer. You'd see that one. But both are okay. Oh, Mr. Mac, you silly guy. All right, here we go. 2 times the quantity x minus 3. Now let's find equivalencies. Well, 2x over x minus 3 is equal to what over 2 times quantity? So this is missing a times 2. Oh, don't do this to me.
Good morning,
times
everyone.
2. Good morning,
In the name of
Dr.
the Father,
Friel.
Son, and Holy Spirit.
Yes.
Lord Jesus,
I'm going to give a second to be respectful.
For companionship found in faith, that you remain with us always, loving with love that knows no bounds. Amen.
Amen.
In the name of the Father, Son, and Holy Spirit.
Amen.
Have a wonderful day.
Thank you. Now, look, with this piece, when we see that they have the same denominator, they're going to have the same numerator. So I'm not going to write an equivalency over here. That's just a waste of time. So you get 4x minus 3 over 2 times the quantity x minus 3. You're not going to simplify that denominator again. We're not going to distribute that out. That doesn't behoove us. All right. Oh, this looks kind of fun. First of all, I'm going to rewrite this with 2x plus 1 over 4 and 2x plus 1 over 6. LCM, 4 is 2 times 2, 6 is 2 times 3. They have a 2 in common. They have a 2 and a 3 as a leftover. So my LCM is 2, what they have in common, and then 2 times 3, which is leftovers, which equals 12. 12, 12, and now equivalencies. 2x plus 1 over 12 over 4 equals what over 12? Well, we're going to multiply it by 3. So we're going to multiply this by 3. This is a pretty good one. This is pretty technical. So we get 3 times the quantity 2x plus 1. 3 times the quantity, 2x plus 1. And now we get 2x plus 1 over 6 equals 12. That's going to be times 2. So we had 2 times the quantity 2x plus 1. So 2 times the quantity 2x plus 1. And now we have to we've got the same denominator, so let's do this. Plus 2 times the quantity 2x plus 1 all over 12. I'm going to make sure it wasn't subtraction. It's not. Now let's simplify the numerator. So we're going to distribute this. That gives me 6x plus 3. We're going to distribute this. That gives me 4x plus 2 all over 12. Now we're going to combine like terms. We have 6x and 4x as like terms, and then we have the constants 3 and 2 as like terms. So that's 10x plus 5 over 12. We're not done. There's lots of stuff here. We're not done, so we can factor that numerator. So we can factor out a 5, and you get 2x plus 1 over 12. And that is it. Perfect. Good. Let's see how many more we got. Well, we got a lot. So I don't know if I'm going to be able to do this before you come into class. All right, 8 and 10. So 8, 2 times 2 times 2. 10 is 2 times 5. 2's in common, so LCM is going to be 2 times leftover times leftover. That's 8 times 5, which is 40. So LCM is 40. We get 5b plus 2 over 8 equals 40. So times 5. So that's going to be 5 times the quantity 5b plus 2. We have 3b minus 4 over 10 equals 40. That's going to be times 4. So 4 times the quantity 3b minus 4. So let's put those all over the same numerator. All over 40. Let's distribute these into the parentheses so we can start simplifying. 25b plus 10 plus 12b minus 16 all over 40. So we got 25b and 12b, which is 37b. We got 10 minus 16, which is negative 6 over 40. We can't factor 37b minus 6, so that would be my answer. 6 is 2 times 3. 9 is 3 times 3. They have that in common. That's leftover. LCM is 3 times 2 times 3, which is 18. Oh, I like the negative here. Mr. Max being aware of the negatives now. So 3y minus 2 over 6 equals how many 18ths? Times 3 times 3. So we get 3 times the quantity 3y minus 2. We have y minus 3 over 9 equals 18. That's going to be times 2. So 2 times the quantity y minus 3. Now this is a good problem because when we put them all over 18, we're going to have 3 times the quantity 3y minus 2. And now we have to be aware of that negative gets attached to the 2. So it's minus 2 times the quantity y minus 3. Let's distribute. We get 9y minus 6 minus 2y plus 6 over 18. 9y minus 2y is 7y. Negative 6 plus 6 is 0 over 18. That's a good one. I like that one. All right, 15 and 10. 15 is 3 times 5. 10 is 2 times 5. That's what they have in common. Leftover. LCM is 5 times 2 times 3, which equals 30. 30. And 30. Okay, so a minus 6 over 15 equals 30s. That's times 2 times 2. So that's 2 times the quantity a minus 6. Oh, I'm going to write it as negative a plus 4 over 10. I'm going to already start writing it in. That's times 3 times 3. So that is 3 times negative a plus 4. Same denominator, 2 times quantity a minus 6 plus 3 times the quantity negative a plus 4 all over 30. And I'm surprised people haven't come in yet. We're going to distribute 2 times a minus 12 minus 3a plus 12 all over 30. 2a negative 3 is negative a. Negative 12 and positive 12 is 0 over 30. Negative a over 30. I'm going to put a mask on. I'm going to open up the door. So you're probably going to hear people coming in as we, oh geez, sorry, microphone's still attached. Let's do this. I know this is a crazy. This is a crazy recording. Putting my microphone back up. All right. 27. You have 12 and 8. 12 is 2 times 2 times 3. 8 is 2 times 2 times 2. Oh, finally, 2 things that they have in common. Leftover, leftover. LCM is 2 times 2 times 2 times 3, which is 4 times 6, which is 24, minus 24. Let's find the equivalencies. 5n minus 2 over 12 equals 24ths times 2. So 2 times the quantity, 5n minus 2. We have 3n minus 3 over 8 to 24 is 3. So we have, oh, I like this. So the 3 is what we're multiplying. And then that is times 3 times the quantity n minus 3. Oh, baby, I like this. Another good one. And a negative. Hello. So we're actually going to combine all those because we would do multiplication. So 2 times the quantity 5n minus 2 minus 9. Negative 3 times 3 is negative 9 times the quantity n minus 3 over 24. So we get 10n minus 4 minus 9n plus 27. Come on in, how are you? 24. Let's do like terms. N plus, what's that, 23? Yeah, 23 over 24. You can take a seat anywhere you like. And nothing can be factored in the numerator. And so that would be our answer. Yes, perfect. Have a good one. Let me know if you have any questions. I'm sure you will with this. This is tough stuff.